Example 4, question 1. The probability distribution function of a discrete random variable x is given in the table below. For part A, we need to find the cumulative distribution function fx. Let's try and find the cumulative distribution table first. We already have px equal to x, and now we need to find fx. Let's recall back. If we have px equal to x, we need to do addition in order to get fx. But if we have fx, in order to get px equal to x, we need to do subtraction. So let's do addition in order to get fx. To get the first fx, simply copy down your first px equal to x, which is 1 over 8. In order to get the second fx, you add the first fx with the second px equal to x, and you will get 1 over 2. To get the last value of fx, you need to add the previous fx with the last px equal to x, and the answer is 1. Make sure that the end value of fx is always equal to 1. For the values of x here, note that x1 is equal to 0, x2 is actually equal to 1, x3 is equal to 2, and x4 is equal to 3. Fx will always start with 0 when x is less than x1. And we already know that x1 is equal to 0. And for the rest of the values of fx, we're just gonna copy down from our table here. So we're gonna have 1 over 8 for the second value, 1 over 2 as the third value, 1 over 7 over 8 as the fourth value, and 1 as the last value of fx. When fx is equal to 1 over 8, x is always between x1 inclusive until x2. And we know that x1 is 0, x2 is 1. When fx is equal to 1 over 2, the range of x is x2 less or equal to x less than x3. x2 is 1, x3 is 2. And for the last value of fx, which is 1, x should always be more or equal to xk, where xk is the last value of x, which is equal to 3. And this is the final answer of finding the cumulative distribution function, or fx. For part B, we need to sketch the graph of fx. And so, to sketch the graph of fx, we're gonna need to use the piecewise function of fx. The x-axis is the values of x, and the y-axis will be the values of fx. And the values of x are 0 until 3. For fx, we can see that we have 0, 1 over 8, 1 over 2, 7 over 8, and 1. Let's do the first one. When x is less than 0, fx is equal to 0. So draw an empty circle at x equal to 0 and an arrow going to the left hand side, since fx is always equal to 0 when x is less than 0. For the second one, fx is 1 over 8 when x is between 0 and 1 and 0 is inclusive. So 1 over 8 is here. So draw a dense circle at x equal to 0, empty circle at x equal to 1 with a straight line connecting the two circles. Continuing, when fx is 1 over 2, the range of x is between 1 and 2 where 1 is inclusive. So 1 over 2 is here, so we're gonna have a dense circle at x equal to 1, empty circle at x equal to 2 with a straight line connecting the two circles. The fourth one, fx is 7 over 8 and x is between 2 and 3 where 2 is inclusive. So 7 over 8 is here. So we're gonna have a dense circle at x equal to 2, empty circle at x equal to 3 with a straight line connecting the two circles. And for the last one, when x is more or equal to 3, fx is 1. So fx is 1 is here, and we're gonna have a dense circle at x equal to 3 with an arrow going to the right hand side. And this is the graph of fx. For part C, we need to find the mode and the median. So let's recall back. The mode is the value of x when px equal to x is the highest. Therefore, if you look at px equal to x, the highest value is 3 over 8 when x is equal to 1 and x equal to 2. What about the median? The median is when, if you can find fm is equal to 0.5, hence the median is the value of m. Therefore, if you look at the table for fx here, we can see that when x is equal to 1, f1 is 0.5. Hence, the median is equal to 1. And that is how we find the mode and the median.